Now that we have the generic code of the library, let's go into the Android port. If this is the first tutorial on building native interfaces you are going through, then here's an important tip. Use the include source feature of Codename 1 and build an Android Studio project. Then implement the native interface within Android Studio. You can then copy and paste the code back into the Codename 1 project. This is far more convenient as you can implement and debug the code right within the native IDE. The same is true for Xcode when working on a Mac. In this case, because the native interface was so simple, albeit large, I skipped that stage, but I have a bit of experience doing this. Most of you would probably feel more comfortable building the Hello World app with the native interface and implementing it in Android Studio. The Android port is trivial. Once we have the native interface, we can right-click on the project and choose Generate Native Stubs, which produces the skeleton code for this implementation class. Unlike before, I'll start with the imports as some of them are a bit challenging. I just imported everything as it was simpler. This is an important helper class when writing native Android code. You will see me use it soon. I wanted one method from the implementation, run on UI thread and wait. It's really useful in some cases. Let's get into the code itself. The view is the camera preview UI. I keep it as a member to return later. The listener is bound later in the code. It just delegates all the calls into the callback. Notice I have only one listener on the native side. All calls are effectively the same. They just invoke the camera callbacks class methods. Android native file paths should be prepended with file URL to work in Codename 1's file system storage. The next step is lifecycle and view methods. After the start method is invoked, I'd like the view object to be valid, otherwise we might have a problem. This code must run on Android's native EDT, hence the need for run on UI thread and block. We initialize the view, bind the listener and start. Notice we can stop and start more than once. We don't need to wait for stop to complete, but it still needs to run on Android's dispatch thread. This method returns a peer component in the Java side. The Android view is translated automatically. The isSupported method is a standard method in native interfaces which defaults to false. When you implement a version in a platform, set it to true. Next, let's do a quick recap of the setter methods in the native interface. We can't use a lambda yet because we are still using Java 5 for Android native code. This might change by the time you see this. We hope to upgrade Android native code for newer builds to use Java 8 syntax, which will shorten the boilerplate here significantly. All of the methods here work roughly in the same way by delegating to the native call via run on UI thread call. I could go for a couple of additional pages of setters, but you get the drift. It's more of the same. Next, we can review the getters, which are shorter. Notice we don't need to use run on UI thread as the getters aren't as sensitive to threading. As you may recall, some of the methods here map to properties of the returned objects, as is the case here and with the preview/capture methods below. Like the setters, this goes on a bit further, so I'll spare you an additional slide where I don't have anything interesting to say. Finally, we have the capture method calls. We need run on UI thread as capture is thread sensitive. Files in codename 1 have file URL prepended, so they will act as URLs. We remove this to translate the file into an Android file. All the other methods are exactly the same. They just invoke the native Android version. This is it for the code, but it won't work yet. We need 3 build hints to get this to work. The camera kit page asks that we add the Gradle build dependency. The codename 1 equivalent of that is the build hint android.gradledep. The page also mentions a ProGuard entry a bit down in the page. This is handled by the android.proguard keep build hint. Unfortunately, if you go through all of that, things still won't compile because of the old build tools version and target. So we need to use the latest version of build tools, which Camera Kit depends on, specifically android.buildtools version 27. This line is a temporary fix. We will soon flip the default build tools version to 27, at which point it will be redundant. Once this is done, we recommend removing it, so when we go to 28, it will use that. Once all of that is done, you should be able to use Camera Kit on Android. The challenge is now iOS.